Hello there, world geographers. It is October 21st or October 22nd, depending on when you get this. If you are an A dayer or a B dayer, hope everybody's having a great day. What we're going to look at for the next couple of class periods are internal forces of the Earth's surface that causes change to the Earth's surface. In other words, what's going on inside the Earth that creates some of our biggest landforms, like mountains and volcanoes and valleys and things such as that, what causes earthquakes and tsunamis and stuff like that. So that's what we're going to be looking at for the next couple of days. We've got this activity that we're going to do, and we've had a lot of video activities lately when it's time that we read a little bit. So we have a little bit of reading that we need to do, and I've got this broken down into several different sections. Section 1 is continental drift. Okay, continental drift, some of you probably heard of. It's the concept that all of our continents were all together in this big old supercontinent called Pangaea, and then they drifted apart and to get to where things are today. And so you'll read about continental drift right here, and then you will give me an answer right down here in complete sentences, please. When you type that in right there, it'll come out red. Sometimes it kind of messes things up. But please type in complete sentences right there in the little green boxes, okay? And you'll tell me how, and then I want you to tell me, after you read this, you'll answer down here, and you're going to tell me on the second question is, how does this really illustrate the theory of continental drift? Okay, so the continents have drifted. They drift on these big plates that we have, and the movement of this process is called plate tectonics. And the process of plate tectonics really is what creates some of the most spectacular features we have on the planet. So you'll read this little description, and then you're going to tell me in your words, in a complete sentence, please, what plate tectonics is. What is plate tectonics? And then on the very last part of it talks about as plates crash into each other, pull apart, grind, or slide past each other, what do they create? List at least 3. I know they list at least 4 in there, things that are created. Now, these plates, if you see right here, here is North America. On the North American plate, here's the Atlantic Ocean. Okay, here's South America on the South America plate. So those plates extend way out into this ocean where they come together. Okay, so the plates can be crashing together, they can be pulling apart, or they can be sliding alongside each other. Okay, so what I'd like for you to do in this one, okay, I would like for you to make sure you read the directions. The arrows indicate the directions that plates flow in constant motion. Oceanic plates are those which exist and flow in one of the Earth's major oceans. Oceanic plates are those which exist and flow in one of the Earth's major oceans. Continental plates exist and flow as a part of the Earth's continents, okay? If you can imagine that the oceanic plates are heavier than the continental plates, so when they collide, the oceanic plates will go underneath the continental plates, okay? But they make some really spectacular things. We're going to see some video on some spectacular things that these plates create, but first we're going to read about them. So what I'd like for you to do is I would like for you to look at the plate direction in the map above, indicate what the plates are doing in relationship with other by highlighting the proper answer, okay? So you're going to find these plate boundaries. So I'm going to, for example, the North American plate boundary and the Eurasian plate, okay? You're going to find where those two interact with each other, and you're just going to highlight. Are they crashing into each other? And so you come up here and you push this highlighter, okay? Are they pulling apart? So if you think they're pulling apart by that map, you're going to come and highlight it like that. Or are they grinding and sliding against each other? Okay, so that's how you're going to answer those. So all you have to do is look at the plates, look at the arrows, and find the plates and see what they're doing with each other. And then finally, as plates collide and spread, okay, they create certain things, okay? They create mountains, and they create fold mountains, and they create volcanoes. They make earthquakes and stuff like that. We're going to read about that, okay? So what we're going to do, I've got this in, this is kind of a diagram of all of the things that plates can do. They can come together, okay, such as right here, this plate's moving this way, and this plate is moving this way. They can move apart as this plate moves this way, this plate is moving this way. Sometimes plates dive below, sometimes plates crumble up, and they create all of these things that we're looking at. So you're going to read about that. In order to do this, here are their directions, okay? Read the following paragraphs, place the proper descriptions in the organizer at the bottom. To help you, the descriptions highlighted in greens are plate movements, okay? So this column has been filled in for you, okay? So everything in green that I put are plate movements. So if I was asked, in the beginning, I was going to ask you to put those down, okay? So you see continental plates collide with each other. There's a couple where oceans and continental plates come together right here and right here. All right, so you're going to come down to this organizer. Okay, so for each of these, you're going to tell me what is formed, and if there's terminology for that process, you're going to tell me. So let's look at the first one. Continental plates collide with each other, and then you're going to give me an example. And all of these are color-coded, really, to make it easy on you. So basically, you put all of the red terminology here and all the blue terminology here. How can I make that easier for you, okay? So like the very first one, talks about mountains are formed in areas where the gigantic plates collide. In some places, continental plates collide with each other. For example, the Himalaya mountain ranges in South Asia were thrust upward when the Indian landmass drifted against the Eurasia. Himalayan peaks are getting higher as the Indian plate continues to move northward and collide with the Eurasian plate. Okay, so I have that diagram to kind of give you an example of that. These are two continental plates coming together. So after reading that, I'd come on down here. Okay, this is where continental plates collide with each other. And okay, kind of with that. So I'd go ahead and fill in mountains here. And is there any process terminology in there? Really, no, there's not any really terminology in there. So I'm going to go ahead and put the example of that, the Himalaya mountain ranges. Okay, so I'm going to do that. Okay, and that's what we do. That's how we do this. And you're going to do that for all of them, okay? So if you look at it, it kind of looks like it's a lot, but it's really not that much, okay? So oops, let me get rid of that. So that's not in there anymore. Okay, very cool. And that is what this is. That is this activity that you're going to do today, okay? When you get done with this activity, if there's anything that you need to do from the previous day's activity, which was titled The Earth Inside and Out, that was this one with the spheres of the earth and the videos and stuff. So if you haven't finished this one, okay, after you're done with internal forces of change, please go ahead and finish that up, okay? All right, that's all there is. I hope that everybody does a great job on this. We haven't done a reading assignment in a while, so we needed to do that today. I'm going to follow this up with some really cool videos later on. So I hope everybody has a great day. Work hard. Let's do a good job.